Hello, this video is to go over section 8.3, the first half of it. In your packet, it's going to be pages 10 through, kind of a lot, I think page 16. All right, so for the opener, had I been in class, we would have gone over this one together, both of them. So for the openers, they say find the value of x. In problem number 1, they give you one side and an angle. We don't know if it's a 30, 60, 90. We don't know if it's a 45, 45, 90. Well, we know that it's not a 45, 45, 90 because they tell you that this is 55. So we're able to find the measurement of the other angle, but we're not necessarily able to find the side length. So if I wanted to find this particular angle measure, I could do 180 minus the 90 minus the 55, so that's 35. But it still doesn't help us find the side length because we don't know anything about a 55, 35, 90 degree triangle. It's not one of our special right triangles. So we can't really do this one yet. For problem number 2, I have 2 of my 3 sides, so I could set up a squared plus b squared equals c squared, but all that's going to give us is what y equals. It's not going to give us this inside value of x. Now maybe we could play around with it. Maybe it's a 30, 60, 90. It's probably not a 45, 45, 90. But right now, we don't have enough information. That's kind of why we're going to need the new skills I'm showing you today. Problem number 3, I just want you to take a peek at this algebraically. If you needed to find the value of x, how would you get x by itself? Well, a lot of you might say divide. Well, x is already being divided. So I'm going to do it. It's going to seem a little counterintuitive, but I'm actually going to move the x. So when I move the x to the other side, and I use multiplication because I was originally dividing by x. So what I have now is x times 16 equals 5. If that's multiplication, I'm going to undo and I'm going to move the 16. It turns out that x equals 5 over 16. So that would be your solution, and that's going to come into play here in a minute. What we're dealing with are something called trigonometric functions, or trig functions. The 3 main trig functions are sine. On your calculator, you will see it looks like sin, but it's really sine, cosine, and tangent. These are functions. Remember, functions pass the vertical line test. They have graphs, all sorts of stuff. We're not going to worry about their shape. We're not going to worry about their graph. We're going to worry about what they do for us relating to a triangle. When you deal with sine, cosine, and tangent, we're talking in terms of an angle, which very often is called theta. This is a Greek lowercase letter. I have a diagram down here where there's a theta and it's representing this angle. They can use x's, y's, lowercase, capital. You're going to see things put in all different places. But when you deal with sine, cosine, and tangent, it's sine of an angle, cosine of an angle, tangent of an angle. What they are is they are ratios. Ratios meaning that they are fractions. So each sine, cosine, and tangent are going to equal the fraction of something over something. Cosine of, I think I said sine tangent. Sine of theta is going to be something over something. Cosine of theta is going to be something over something, and the same thing with tangent. So we have to figure out the somethings that go here, and I'll walk you through it. Identifying the angles and the sines. When we deal with sine, cosine, and tangent, you're looking at 3 particular words. We're dealing with opposite, a particular angle, adjacent, a particular angle, and the hypotenuse is always opposite the 90 degree. Depending on your point of reference, by point of reference I mean depending on where the angle is located that we're working with, your opposite and adjacent may change. So looking at the first triangle here, and looking at theta, located here, which side length is opposite? Opposite meaning all the way across. This side length over here is opposite. When we talk about adjacent, we mean next to. So the one that's next to theta is here, and the hypotenuse is always directly across from the 90 degrees. Pause the video for a moment and try filling out opposite, adjacent, and hypotenuse for the second triangle. Hopefully you paused it, gave yourself a practice. Who's going to know whether you paused it? No one, except you're losing out on practice. So next time, pause it. So for problem 2, we're looking for opposite. Theta is now up here, so opposite is still all the way across the figure. If that's opposite, then adjacent is next to it. And hypotenuse is always the longest side that's across or opposite the 90 degrees. These 3 words are going to be used, and it's going to seem a little bit confusing, but it all comes back to, can you identify what is across, meaning opposite, what is adjacent, meaning next to, and then which one is the hypotenuse. Sine is abbreviated SIN, and it's sine of a value. You might see sine of A or sine of X or sine of a number, but this value in here is a degree. The sine is equal to the ratio, meaning it's a fraction, of the opposite side over the hypotenuse. So what I have on this yellow triangle is I have a particular theta, opposite meaning across, and hypotenuse across from the 90. We will use sine theta whenever you have a value in the position of the opposite and whenever you have a value in the position of the hypotenuse. Will be sine of theta. So let's give a couple practice with sine. For the first handful, all we're doing is setting up the problems. I'm telling you to use sine, so you're looking for opposite. The value that's opposite is going on top of your fraction. The value that is the hypotenuse is going on the bottom. It's a fraction. So for the first one, my sine of theta, which one of those 2 values is opposite theta? 6 is my opposite. And which of those 2 values is the hypotenuse? The 10. So the ratio that we're setting up, I want the box to move, is the sine of theta equals, think about it as 6 over 10. All I did was reduce. Your calculator would be capable of doing that as well. Looking at the middle triangle. The triangle is turned, so opposite and hypotenuse may be a little bit harder, but find theta. That's your reference angle. What is opposite theta? The 2. And what is the hypotenuse? The 7. So when you go to set up this fraction, you're writing sine of theta equals, you're setting up the fraction as the opposite on top and the hypotenuse on the bottom. For the third one, pause the video and give it a shot. All right, so there's your answer. The sine of theta equals 4 over 9 because 4 is the side that is opposite, and that value always goes on top of the fraction. And the 9 is your hypotenuse. So you're probably thinking, what are all of these fractions? What do we do with this? How is this actually helping? So let's look at a problem like the bottom 3. It says, find the value of the variable in each triangle. Round to the nearest hundredth. Use the ratios above to help you. So essentially what I've done is I've taken the same triangle here and I've copy and pasted it. The only difference is instead of theta, I've actually given you an angle. So this is going to be something that you can compute, something you're going to type in a calculator. Hopefully you have a calculator with you. So recognizing that the theta is now a 60, this is still my reference angle. From here, I realize I have an opposite and I have a hypotenuse. Sine is always sine of a degree equals opposite over hypotenuse. So I'm going to say that the sine, and instead of putting the theta, I know that it's a 60. Sine of 60 equals the fraction is the opposite. Well, instead of a number here, I have a letter x over hypotenuse. I know this looks weird, but we have to figure out how to type this in a calculator. I need to get x by itself. How do I do that? The x is on top, the 10 is being divided. So to undo division, I'm going to multiply. 10 times the sine of 60. You're going to need a calculator, hopefully one of the TI products, so the little scientific calculators you use, or even a graphing calculator, although there may be an issue with your grapher if that's what you're using. I'm going to use Desmos online. Okay, so you're going to need a calculator. I'm going to use Desmos because it's free, it's out there, it's fabulous. Make sure if you're using Desmos or your big graphing calculators that you need to be in degree mode, not in radian mode. I need to be in degrees because this value it's going to give you, this 60 is in degrees. Radian is another type of measurement. So when I do that, click degrees, I typed in 10 times. When I went to hit sine, sine is in this function menu. It automatically gave me those parentheses because it's always sine of a particular degree. And it ends up being 8.66. The direction asked you to round to the nearest hundredth. So x equals 8.66. So the purpose of what we're doing is given one angle and given one side value and an unknown side value, well, given one angle and a side value, we're able to find an unknown side. So it opens up a different variety of options other than just Pythagorean theorem, 45, 45, 90, and 30, 60, 90. I'm going to ask you to pause the video and attempt to set up the next two, and then you can restart it and check your answers. Okay, so hopefully you set up your fractions. I saw the 55 in the second problem. There's my opposite. There's my hypotenuse, so opposite went on top and hypotenuse went on bottom. I'm going to hold out on solving that one for a moment. For the next one, I saw the 37. My x was opposite, so it went on top. My 9 was hypotenuse, so it went on bottom. How do I get x by itself? I multiply both sides by 9. So 9 times the sine of 37 is equal to x. That ends up giving us 9 times sine of 37, ended up equaling 5.12. And now the middle one is the harder, did I say, I think I meant that to be a 4. Okay, the middle one is the harder of the two to set up. We want to get x by itself. So just like that warm up, we're actually going to have to move the x value here. So we get x times the sine of 55 equals 2. I want to get x by itself, so I want this entire sine of 55 to move to the other side. And I know it's weird, but sine of 55 is just your calculator. If you don't believe me, type it in. So what we need here is x is going to equal 2 divided by sine of 55. So I'm going to go to my calculator and do 2 divided by sine of 55. And it's 2.44. I'll get there. That concludes sine. Next video will go over tangent.